So when we have more complicated equations, we need to go beyond just kind of using our knowledge and actually have a method that we use to solve our equations. We're going to get to that, and we're going to get to an idea where we're going to use inverse operations. And to understand that a little bit better, we're going to go back to what that equation is telling us to do. So when I see 4x plus 3 equals 11, what it means is take a number, I times it by 4, I add 3, and the answer is 11, okay? So I'm just going to write that as like a string of operations, if you like. So I take my number, which is x, I times it by 4, and then what I do next is I add 3, and that means that the answer is then 11. Now, inverse operations is a way of reversing all of those steps. So we do the opposite of what we have. So we start with the answer, and we do the opposite. So the opposite of adding 3 is to take away 3. The opposite of timesing by 4 is to divide by 4, and that ends up with our number that we started with. So if I follow through now my backwards calculation, so I start with 11, I take away 3, that gives me 8, I then divide by 4, the answer is 2. So for 4x plus 3 equals 11, the answer will be 2, okay? Let's see that in action couple more times. So here we've got 5x minus 7. So I start with x. What I'm told to do is to times by 5, because I need to do the multiplication first. I then subtract 7, and the answer is 28. So reversing that, I'm going to start with the answer. The opposite of taking away 7 is to add 7. The opposite of timesing by 5 is to divide by 5. And then I get my number I started with. So 28 plus 7 is 35. 35 divided by 5 is 7. So the answer to this equation, or the solution to this equation, is 7. Okay, one more time. Here we've got a number, x. We times it by 3 first of all. We add 1. And we get 8. So reversing that, we start with 8, we take away 1, we divide by 3, and we get our number that we start with. So 8 take away 1 is 7. 7 divided by 3, well, we don't have a whole number there, but it's still a number, and I can write it as 7 divided by 3. I could give it as a fraction. Okay, so not all of your equations might result in a nice whole number at the end of it. Sometimes we have fractions as our answers. Okay. So what we've been working with here is the idea of inverse operations. So when the opposite of adding is to subtract, the opposite of subtracting therefore is adding, and with multiplication the opposite is division, and with division it's multiplication. And so we can take that idea then and formalize our mathematical communication, because having to write out these big long chains all the time might work for these equations, but when you come to look at more complicated examples, you're going to need this idea that we can use inverse operations, but also use them to balance out our equations. So we're going to use inverse operations, but we're also going to use the idea that equations are balances. So this equation at the moment is balanced. It's saying that 4x plus 3 is equal to 11. Okay, so if you imagine it like a set of scales, they're balancing at the moment. But I want to unpick this and do things to each side so I get x by itself. Now, so first of all, I want to isolate the term with the x in. I want to get this bit by itself. So it means that I need to get rid of 3. So the next stage in my equation is to say, okay, well 4x plus 3, but I want to get rid of the 3, so I'm going to take it away. Now because my equation is a balance, whatever I do to one side of the equation, I have to do to the other. Okay, so you can see that subtract 3 appears on both sides. So if I add 3 and take away 3, that will disappear. So what I'm left with is just 4x here. And then on this side, 11 take away 3 is 8. Now that actually works with what we saw before, because what we saw before was that we had to start with 11 and then take away 3, and we ended up with 8. Okay. Now we've got here, okay, so this is really saying 4 times a number equals 8. Well, the opposite of multiplying by 4 is to divide by 4. And again, whatever I do to one side of the equation, I do to the other, okay? So 4 divided by 4 gives me just x, just that number back again. And then 8 divided by 4 is 2. Now let's cross-reference this with what we did before with these chains. So we took away 3, then look, we divided by 4, and we ended up back with our number, which we said was 2. And so this is also saying the same. We divided by 4, we get the answer of 2. So we're using the idea of inverse operations, balances, so whatever you do to one side of the equation, you do to another. Let's just see it with one more example here, so you get a taste for what's happening. So we've got our 5x minus 7 equals 28. So a number times 5, take away 7 equals 28. So we want to undo that take away 7 first of all. So the opposite of subtracting 7 is to add 7. So I start with this, but then I want to undo that take away 7, so I add 7. And then whatever I do to one side of the equation, I do to the other. So plus 7 and minus 7 equal to 0, so that gets rid of that. And then I can work out the rest, so I'm left with 5x here. 28 plus 7 is 35. What this equation is saying is 5 times a number, okay, is equal to 35. And the opposite of multiplying is to divide. So I divide one side by 5, I've got to divide the other side by 5. 5 divided by 5 cancels, and then I'm left with x, and 35 divided by 5 is 7. So we get the answer of 7. Let's compare to what we did with the chains. We started with 28, we added 7, we got 35, we got that, and then we divided by 5 and we got 7. So we added to 7 as we saw before, we divided by 5, we got the same answer. This is a much more formal way of writing down how we solve equations, and is going to be more useful to you as your equations get more complicated. So you do need to know how then to start to understand and use what we call the balance method, where we use inverse operations, and the golden rule is whatever you do to one side of the equation, you do to the other. Okay, and that's our golden rule. So I'm even going to put over yellow highlighter and make it all nice and golden, because it's that important.